Assalamualaikum warahmatullahi wabarakatuh. The Honorable Mrs. Lisa Tania, SPD MSc, as a lecturer of English for Specific Purposes course and all of my friends. In this opportunity, we want to show you our learning scenario about the concept of redox reaction. The roles of students will be played by Ihda Zulfa, Feralia Safitri, and myself, Putri Salsabilla, and the role of teacher will be played by Putri Anggun Masytoh.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, student. How are you guys today?
Morning, ma'am. I'm good. How about you, ma'am?
I'm good too. Thank you for asking. Are you guys ready to study now?
Ready, ma'am.
Okay, before starting our lesson today, let's pray first. Class leader, please comment your member.
Okay, ma'am. Let's pray together. Finish.
Well, everybody, pay attention please. I will check your attendance. Nice. Let's check to see who's here today. Bila, are you present?
Present, ma'am.
Okay. Danu, are you present?
Danu is not present, ma'am. Yesterday, he sent an excuse letter due to sickness.
I hope he is okay. Give me the letter after I take attention, please. Next, Feralia, are you present?
Present, ma'am.
Zulfa, are you present?
Present, ma'am.
Today, we are going to learn about reduction and oxidation reaction. First, take a look at the picture. Are you guys familiar with this phenomenon?
Yes, ma'am.
Can someone explain it?
I want to explain it, ma'am.
Sure.
I often see the rusty fences. The picture shows iron corrosion. The rusting of the iron is caused by air.
Okay, thank you. Actually, iron rusting occurs due to a reaction involving oxygen. Do you know what this reaction is? Rust on iron is formed due to a reaction between iron and oxygen in the presence of water or water vapor in the air. This rusting process is known as the oxidation process. Have you ever heard about oxidation and reduction?
I haven't, ma'am.
So, the reduction and oxidation reaction is commonly known as redox reaction. There are three concepts in this reaction, namely oxygen transfer, electron transfer, and change in oxidation number. Now, we are going to learn about the first concept. Take a look at the sum of this reaction. I give you 5 minutes to observe the reaction that I present. Try to see the difference between the two types of them. You guys can discuss it with each other.
All right, ma'am.
Okay, time is up. Bila, can you explain what you got? Compare on reaction from each.
Yes, ma'am. One of the oxidation reaction is the reaction between zinc and oxygen to produce zinc oxide. Meanwhile, in the reduction reaction, there is a reaction where copper oxide loses oxygen to produce copper and oxygen.
So, what you can conclude?
Oxidation is a process in which a substance is react with oxygen to produce oxide. Reduction is the removal of oxygen from a substance. In other words, oxidation is the gain of oxygen and reduction is the loss of oxygen.
Great, thank you Bila. At this point, does anyone have any question?
Ma'am, I want to ask. Are redox reaction only present in reaction containing oxygen?
Good question, Vera. Can someone answer Vera's question? This relates to the three redox reaction concept I mentioned earlier.
I'm not sure, ma'am. However, I think redox reactions can also involve electron transfer. So, not all redox reactions occur in oxygen-containing compounds.
You are right, Zulfa. Previously, I mentioned that three are three concepts in redox reaction. It means three is development in the concept of this redox reaction. Not all compounds contain oxygen, so another concept of redox reaction was developed, which is based on electron transfer.
Oh, I see, ma'am.
Now, we can move on the next concept, look at this reaction. From the table, how is the electron transfer that occurs in the oxidation reaction?
I think in oxidation reaction, electrons are gained, ma'am.
What about reduction?
Conversely, in a reduction reaction, electrons are less, ma'am.
Bila, do you have any views on that?
My opinion differs from theirs, ma'am. Based on the reaction on the table, I think oxidation is the loss of electrons and reduction is the gain of electrons.
Can you explain it?
In the oxidation reaction, 2Na turns into Na plus 2 electrons. The electrons in the right side of the equation indicate that it's being spit out. That means Na is losing the electron. Meanwhile, in the reduction reaction, S plus 2 electrons give S2 minus. It means sulfur is gaining electrons.
That's great. Thank you for your opinion, student. But Bila's opinion is correct. As usually, we can conclude what a redox reaction is based on the concept of electron transfer.
I want to try it, ma'am. The oxidation is the process of loss of electron. The reduction is the process of a gain of electron.
Ma'am, what if based on the first concept a reaction is an oxidation, but the second concept the reaction is not an oxidation?
Good question. To explain that problem, the concept of change in oxidation number was developed. Let's move to this concept. In this concept, there are several rules. You can see the table that I display or see in your book on page 171.
Okay, ma'am.
A substance is said to be oxidized if it undergoes an increase in its oxidation number. Conversely, a substance is said to be reduced if its oxidation number decreases in the reaction.
I still don't get it, ma'am. Can you give us an example?
Sure, this is an explain of the redox reaction based on this concept.
Ma'am, we know that the oxidation number of free elements is 0, so zinc and copper have a 0 oxidation number. The oxidation number of a monoatomic ion is equal to the charge on its ion. So, the oxidation number of Cu2 plus is plus 2 and Zn2 plus is plus 2. Is this correct, ma'am?
Brilliant!
There are rules about the sum of oxidation numbers in compounds. Is this used to calculate the oxidation number of the element that we don't know, ma'am?
That's right, you just need to use basic algebra. Do you guys still have questions?
Nothing, ma'am.
Okay, I think it's enough for today. I will give you a process about this material. Do the exercise on page 174. If you still have questions, you can ask me or your friend.
Okay, ma'am.
Hopefully, what we have learned can be understood well. See you next week and have a nice day. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, ma'am.